video, we discuss this paper pre-PSPM, KMPP, extra. So first is part A. Part A, 10 question, 10 marks. Okay, look at the first number 1. Okay, given the info, this is info. Okay, then find the limit. So look at this one. Let's say you know nothing, just substitute directly, then get the answer. Say you substitute here without writing the limit. Okay, square root of 3, 4 minus 2, negative 2. Then answer is 12 plus 4 is equal to square root 64. Okay, and then get answer. So this is not the correct concept, but to get faster answer. Let's say you want to do the correct concept. Okay, let's do the correct concept. Square root. Okay, take square root outside. Okay, square root, limit, or you can separate the 3, take the 3 here. Okay, limit h x approaches t minus 2, limit kx approaches t. The next step, substitute 3. So here is given, here is 4, right? 4, negative 2. Then simplify and get the answer is 4. Okay, so you have two methods. For objective, you can take this one. Okay, faster than this. Okay, 2 is find the limit of this one. First substitute. This is negative 1. Okay, negative 1, substitute negative 1. Okay, 1 minus 1, 0. And 1, okay, this is minus 5. 1 minus 5 plus 4 is equal to 0. This is called indeterminate form. Then 1 indeterminate form as a purchase value. Then this one is polynomial or polynomial. Okay, so we should factorize. Okay, factorize. Okay, factorize this one equal to limit, okay, x minus 1, x plus 1 over x plus 1, x plus 4. Okay, so x approaches negative 1 from right. And then simplify, cancel this one. And this one is equal to limit x minus 1 over x plus 4 as x approaches negative 1 from right. Then substitute negative 1 minus 1, negative 1 plus 4. Then the answer is negative 2 over 3. The answer is negative 2 over 3. Okay, actually you can use calculator, and certain calculator can give the answer. Okay, for this one, just substitute this one. Okay, using calculator, then calculate, and this is negative 1. Okay, let's say this is 0. This is negative 2. Okay, this is left, right. Negative 1 from right is here. Substitute x is equal to negative 0.9999, and to get this is around this answer. Okay, you can check using calculator. So for number 2. Number 3, find the limit of, okay, x tends to infinity. Given this one, power negative, power positive. So now check, and this one is to the power negative x equal to 1 over 2 power x. Okay, and write the limit, 1 over 2 power x over 2 power x approaches infinity. And if this one have problem, you can let u. Let u is equal to the power x and substitute. Okay, so limit this one just substitute u over equal to 1 over u and substitute this one to variable x to power s squared. The next is substitute infinity. Get 1 over very big number, or 1 over infinity is equal to 0. Let's say you have 1 ringgit, divide to 100 students. Okay, of course, you get almost 0, right? So this one is equal to 0. Okay, number 4. Given this is piecewise function. Okay, so for piecewise function, this part is domain and domain or x value, and this part is range or graph or y. Okay, graph or y, this one x. So for piecewise, okay, later change to number line. Okay, talking about the when x is equal to 1, x not equal to 1. Okay, so here 1. Okay, all except 1. Okay, here all except 1. The function is, okay, this function that is x squared minus 1, x squared minus 1. Then when x is equal to 1, y is equal to 1, 4. 1 coordinate. Okay, 1 point. So when x is equal to 1, here just a point. Okay, now this one, okay, we need to consider at here when x is equal to 1. Check. Now, the statement looks like this one is test to test continuity. So for the first part, first is f of 1. F of 1 given is 4, or here 4. Okay, so f of 1 is 4. Define exists. The value is 4. So we can say f of 1 is settled. And the second step is limit. Limit x approaches 1. Okay, here is left and right. Since this one is same function, so just find x approaches 1 for the limit. Okay, then substitute is equal to 1 minus 1, 0. So the limit also exists. The limit also exists. And the next step is it number 1 is equal to number 2? Number 1 is equal to 4. Number 2 is equal to 0. So here is not equal. Actually not equal. Limit fx as approaches 1 not equal to f of 1. So conclusion, f is not continuous at x is equal to 1. So the statement here, f is continuous at x is equal to 1 is not true. So answer is true, 1 and 2 only. This is the answer. Okay. Okay, number 5. Number 5 is given in terms of first principle. Okay, so here actually for first principle, limit fx plus h minus fx over h as h approaches 0. Okay, and mesh. This is fx. We want fx. So fx, okay, fx is equal to x cubed. Okay, and then find the f and differentiate f for the first derivative. F prime of x is equal to 3x squared, and get the answer. Why? Because of this one is first principle to find the dy dx. Okay, so settle for number 5. Number 6. Okay, this one is differentiate this one. Differentiate this term. And here you see the power rule from outside to inside. So 3 squared, and then you need to differentiate whatever inside the bracket. Okay, so now here is Okay, first is copy. Copy 2x, then differentiate ex. Here is ex. Okay, let's copy. And then differentiate 2x, okay? So the answer is 3ex plus 2x squared ex plus 2. So the answer is this one. Okay, make sure differentiate this one to get this. Okay, number 7. Okay, this is implicit. Find dy dx. So here is set x plus set y is equal to set a. Set a is constant. Okay, so differentiate this one implicitly. Differentiate set x get 1 over 2 set x plus 1 over 2 set y, and always after differentiate y, add dy dx is equal to this constant c. If you're not sure, just change set x to x to the power of half and differentiate. Still get the same one like this. So we're going to find dy dx 1 over 2 set y dy dx is equal to negative 1 over 2 set x. You can bring to one side. So dy dx is equal to negative 1 over 2 set x over 1 over 2 set y. So using this concept, a over b, ac over d, a over b over c over d is equal to a over b times b over c. Okay, so now, okay, continue this one. Dy dx is equal to negative 1 over 2 set x times 2 set y over 1. Simplify. Here is, okay, we cancel this one. And here is negative set y over set x. Okay, check answer. Oh, the answer is given in 1 square root or set y over x. Negative set y over x. Answer is here. Okay, that's for number 7. Number 8. Number 8 is also find dy dx. Given y equals x cubed times ln x. So now you have two different functions. This is considered uv. So y is equal to uv. Y prime equals u prime v plus uv prime. You need to use product rule. Okay, so find u. U is equal to x cubed. V is equal to ln x. U prime or du dx is equal to 3x squared. V prime or dv dx is equal to 1 over x. Okay, now, okay, here times u prime times v, okay, plus u times v prime. So, dy dx is equal to 3x squared times ln x plus 3x squared times 1 over x. Okay, simplify. 3x squared ln x plus, cancel this one, so get 3x. Okay, answer, this is the answer. Okay. So number 9. Number 9 is given this one, this function, then y. Okay, we need to check whether this y has a relative maximum or minimum, or neither relative maximum or minimum. Okay, so now, okay, this is the one. Okay, let's say the graph is like, or you differentiate dy dx 3x squared plus 2x plus 1. Okay, to find the relative maximum minimum happen when dy dx is equal to 0. So now 3x squared plus 2x plus 1 is equal to 0. Okay, and try factorize and your calculator give answer in complex number. Okay, means this is no root. Okay, no root, and then no maximum or no minimum. Okay, and actually the graph, or you can check using the discriminant. And substitute 4 minus 4 times 3, 12. Okay, 1. Okay, so 12. So it's negative 8 less than 0. This one also complex number. Actually, the graph is like this. The graph, okay, when substitute here, y is equal to 1. So 0, 1 is, okay, intercept point here. So the graph is like this. Okay, so 1. From the graph shows that no maximum and no minimum. So this is the answer. Okay, this is here. Number 10, given that x is equal to 1, fx attains a maximum value. Here is maximum value in this interval. Okay, find value m. Maximum. Okay, maximum. Okay, means you need to differentiate this. Find f prime of x for x cubed minus 1 to 4x plus m. Okay, maximum f of x is equal to 0. So 4x cubed minus 1 to 4x plus m is 0. Okay, it's happened when x is equal to 1. So substitute 1. Okay, then 4, 1 minus 1 to 4, 1 plus m is equal to 0. 4 minus 1 to 4 plus m is equal to 0. And therefore m is equal to 1 to 0. So it is 1 to 0. Number 11. What is the polar form of the complex number? This one. Okay, this one. To find the polar form. Okay, so for polar form, the pattern for polar form is z is equal to r times cos the theta plus I sine. So you need to find z to find r and find theta. So starting from I to the power 15, okay, power 3 is equal to I to the power 45. And you need to remember that I is equal to z negative 1. I squared is equal to negative 1. So I to the power 4 is equal to 1. Okay, this one. Then need to simplify this one. I to the power 45 is equal to I to the power 4, okay, times 11, then times I. So 44 plus 1 is equal to 45. Okay, 44 plus 1 is equal to 45. And the next step is, okay, here, okay, I power 4 is equal to 1. Substitute 1. Okay, the next step, 1 to the power 11 is 1, and I. Answer is I. So we can conclude, okay, z is equal to 0 plus I. Okay, then r, or modulus of z, r is equal to this one, 0 squared plus 1 squared is equal to 1. And theta, or argument of z, is equal to tangent y over x, 1 over 0. 1 over 0, and you check calculator, kita give answer undefined, okay, or max error. So look at this. Okay, look at this. Z, you get this I, only I. So let's say if you change to Argand diagram, and Z, okay, Z is equal to I means this line is vertical line. Theta from this Argand diagram, theta is equal to pi over 2. Okay, here. So we can say this one is pi over 2. Okay, so find the polar form. The polar form is 1 times cos pi over 2 plus I sin pi over 2. Okay, check answer. Okay, this one is negative, not the answer. This one is negative here, angle, not the answer. This one is over 3, not the answer. So cos pi over 2 plus I sin pi over 2, this is the answer. Okay, settle for number 11. Number 12. Okay, given this one, 1 plus I, 1 plus A power P plus Q plus 1 over 1 plus A Q minus. So here, okay, the difference is negative. Standardize 1 over 1 plus A. Let's say take negative outside, so change to Q minus P. Then plus 1 over 1 plus A power Q minus P. So you can let U is equal to A to the power negative Q minus P. A is equal to 1 over 1 plus A power Q minus P negative 1. Okay, plus 1 over 1 plus A Q minus P. So just substitute. Okay, 1 plus 1 plus 1 over 1 plus something. So something is U. Okay, simplify here. Is equal to 1 over 1 plus 1 over U plus 1 plus U. This part, okay, try to simplify this part. Okay, and then equating the denominator, and get U over U plus 1 plus U plus 1. 1 plus U equals U plus 1. Okay, and check, this is the same denominator. That's right, U plus 1. So here U plus 1. U plus 1 over U plus 1 is equal to 1. So answer is 1. Number 13, determine the value of x, where x integer, given this one. So check, this is base 15, base 15, base 15. Now the problem is this one, x, term x. Okay, so that okay, it's better for you to change to the same base. Okay, then okay, right, x, so x is equal to log, we want base 15, so 15 power x. Using the third rule, bring x to front and log 15, base 15 is equal to 1. So answer is okay. And then okay, change this one to this part. Okay, and this one to this one. Here, right here, log 15 power x base 15 plus log 1 plus 3 power x base 15 is equal to, okay, log 5 power x base 15 plus log 12 base base 15. So we're going to use the rule, the first rule or the first law of log. Log m plus log n is equal to log m times n. Okay, so now simplify. This one consider m n. Going to change to this form using the law of log. Okay, so log from 2 log change to 1 log. Okay, log m, this is m times n, 1 plus 3, okay, and is equal to same procedure for this one. Okay, this is m, this is n, change to okay, 1 log, 1 single log, and here is log m, this is m, okay, 5 power x times n, okay, 12. Okay, then base, the same base, 15, 50. Okay, step. Since this one the same base, okay, so whatever inside the bracket consider equal. Okay, then make sure you cannot cancel this one. Then simply, oh, here is 15, 5. 5. So try to simplify. Okay, 12, 5. This one is over. Okay, 15. 15 is here. 15 power x is equal to 3 times 5 to power x is equal to 3 power x, 5 power x. So 3 power x, 5 power x. And check. Same answer. Okay, then simplify. 1 plus 3 power x is equal to 12 over 3 power x. Let's say let u is equal to 3 power x. Okay, so that get 1 plus u equals 12 over u. Taking the denominator. Okay, the answer. And you get u plus u squared. Get quadratic. Okay, quadratic. Factorize. U plus 4, u minus 3. Okay. The next step. U is equal to negative 4 or u is equal to 3. So what is u? U is equal to 3 power x. 3 power x. Therefore, x is equal to 1. This one just not the answer or ignore. Okay, so answer is only 1. Number 14. What values of x will be the solution to the inequality? 15x minus 2 over x more than 1. Can bring 1 to the left. Okay. And equate the denominator. 15x squared minus 2 minus x over x. Make sure over x. Okay. Then this one is quadratic over x. It should be over x. So 15 is 5x, 3x, and 2. 2 is 1. It should be 2. 1 minus. So get the same one. Or you use calculator EQN to find this. Okay. And so according the bracket 1, 2. So 1, 2. Here write down 5x minus 2 more than 0. 3x plus 1 more than 0. X more than 0. And simplify. X more than 2 over 5. X more than -1 over 3. and x more than 0. And using the number line, and check the value. Okay, this is negative 1/3, 0, 2/5. Okay, so inverted line. Okay, this is boundary. Okay, and here is for this part. This part for this one. Okay, for this one, x more than negative 1/3. Okay, not included. To the right. Line shows positive, no line negative. Then the next step is for this one, x more than 0. X more than 0 is to the right. Line positive, no line negative. Okay, and the next is this one, x more than 2/5. More than 2/5 is to the right. Line shows positive, no line negative. And the next is, this one is negative. This is negative, positive, negative, positive. Okay, positive times positive over positive, positive. Negative times positive, negative over something like that. Okay, so we want this region. Okay, then is everything more than 0. We need positive. It's not positive. So from here, the answer is okay, negative 1/2 to 0, union 2/5 to infinity. So answer is negative 1. This one, this is the answer. Okay. Number 15. What is the solution for this one? Okay. Modulus x minus 2 over x minus 2 more than 0. The problem is here. Okay. Okay. We should define this one. Define this. Okay. So x minus 2. Okay. Positive x minus 2 when x more than 2. Okay, negative x minus 2 when x less than 2. Then 0 when x is equal to 2. Okay, or let's say we are going to separate this one because of here is not included. Or change this one to number line. Number line. This is domain right. Okay, so to the right, positive x minus 2. To the left is negative x minus 2. And 0 when x is equal to 2. Okay, so you have we have two cases here. The first is this one. When x more than 2. When x more than 2, the first case is when x more than 2. So here, x minus 2 more than 0, this part change to x positive x minus 2. One can be cancelled is equal to 1. 1 more than 0. Okay, so this one more than 0. For the case here, the second case, okay, when x less than 2, x less than 2, okay, so x minus 2 over 0, this one change to negative x minus 2. Okay, then this one also can be cancelled and get negative 1 more than 0. Okay, and okay, if you compare between these two statements, okay, this one confirm it is wrong statement. So we accept only this one. 1 always more than C. So it happens when x more than 2. The answer is 2 to infinity. Okay. Number 16. Okay, fx is equal to 3x plus 2 over 5x minus 3. Okay, then check, oh, this is inverse. So try to find inverse. Given this one, try to find inverse. Let y is equal to 3x plus 2 over 5x minus 3. Okay, for this one, okay, we're going to write x in terms of y. So since this one is objective, we don't have to follow all the steps. Okay, just your aim is to write x as a set. Okay, so 5xy minus 3y is equal to 3x plus 2. So okay, bring 3x to the left and 3y to the right. Factorize x. Okay, and then okay, 3x as a subject, 3y plus 2 over 5y minus 3. Okay, this is actually f inverse. So f inverse is equal to 3x plus 2 over 5x minus 3. Okay, and check, oh, this one is same like f. Fx. So you can say f inverse is equal to fx. This is just purposely the working is because of the question is object. If not, you need to change to f inverse y is equal to 3y plus 2 over 5y minus 3 and change back to variable x. Now here should write fx is equal to y, f inverse y is equal to x. Okay. Number 17. Identify domain and range for function fx and define n. N is natural number. Okay, starting from 1, 2, 3 up to infinity. Okay, so given the piecewise function, okay, from here this is domain. Okay, domain, and this is range. Define range of the graph. Okay, and from here, okay, change to number 9. Okay, so check the first one. The first is domain from 1 to 2. 1 included, then circle. 2 is not included. The function is 1 plus x. When, okay, from 2 to 4, 2 to 4, okay, 2 is 10 circle. Okay, 2 to 4, 4 is empty circle. Okay, just write different level for this one to show the different function. This function is 2x minus 1. Next step is when domain is from 4 to 6. 6, 4 included. Okay, the function is 3x minus 10. Okay, now we're going to find the domain. Domain, this one refer to domain. Oh, this one refer to domain. Okay, so this is domain. 1, 2, 4. Confirm 1 to 4 is the domain. But not sure that there is a number between 2 and 4. 3 lies on the line, then circle included, so consider also domain. Same as number 5 also lies on this line, consider domain. So domain is 1, 2, 3, 1, 2, 3, 4 and 5. Okay, that is domain. And from this given option, Then the domain, this is domain, this is range. As you can see, this one only, this option shows the same as yours. Okay, so this the answer is, the option is here. Okay, just be check, just check. Okay, let's say you consider change the domain to the mapping form. KMPP, this is domain, range, and the number is in the domain is 1, 2, 3, 4, 5. Okay, so when x is equal to 1, we substitute in this function. 1 plus 1 is 2, so it maps to 2. Okay, when 2 x is equal to 2 here, we take this function. 2 times 2, 4 minus 1, 3. So 2 maps to 3. Okay, the next step, 3 lies the same function. Substitute 3 times 2, 6 minus 1, 5. So 3 maps to 5. Okay, next step, substitute when x is equal to 4 here. Substitute in this function. 3 times 4, 12 minus 10, 2. So 4 maps to 2. The last is 5. Substitute also in this function. 3 times 5, 15 minus 10 is 5. So 5 maps to 5. Okay, here is domain. Domain is 1, 2, 3, 4. And here is consider range. Range only 2, 3, 5. Okay, this is 2, 3, 5. So this is the answer. So for this one is not the answer. Why? Because of the domain is here. Just consider this point, this, and this. Okay, number 3 and 5. This one, this one is not considered. Okay. Number 18. Use the correct statement that corresponds to the graph shown. So here is talking about domain. Domain, domain, domain. So when domain is just check the value for x. Okay. And the next step is domain discrete. Discrete is can be counted 1, 2, 3, 4, 5. Continuous, 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 continuous. So from the given graph, the graph is continuous. If discrete, the graph is same like this. If discrete, so this answer is cancel. Not the answer. Not the answer. So you have B or C. And check. The next step is check the statement. Domain is the domain function is here negative 3, 5. Here is negative 70 to 150. And check this is actually from the graph. This is negative 3. Negative 3. And here is 1, 2, 3, 4, 5. So from negative 3, empty circle is empty circle. 2, 5, then circle. So x lies here. So this is match for this option. Okay. And double check. Okay, so settle. This is the option. This is not the. So the answer is B. Number 19. Given f of g of x equals g of f of x equals x. Given fx, find g from this statement. Okay, looks like this is same like the properties of the f inverse. Say f inverse of x is equal to x, or f inverse f of x is equal to x. Let's say choose this one, same like this. Okay, and this one is f of g of x is equal to x, and okay, this one, and this one g, just this one. Okay, so this one is g of f of x is equal to x, and then we can say from here we can conclude that f inverse is equal to g. F inverse is equal to gx. Conclude f inverse is equal to gx. we're going to find G. To find G means that to find F inverse. Okay, so now find F inverse. Okay, let Y is equal to AX squared plus B cubed. Okay, and Y power 1 over 3 AX squared plus B. Take X as a subject. Okay, and AX squared is equal to Y power 3 plus minus B. Okay, the next step, X squared is equal to Y power 1 over 3 minus B over A. Okay, so now this one is square root and square root this one. Okay, and then you get actually plus minus 2. So because of the answer is considered plus only, just use the plus. Okay, so here you can conclude F. Okay, F inverse G is equal to G is equal to X power 1 over 3 minus B over A. Okay, and power 1 over 2. Okay, so check the answer. No, and this is the answer. Okay, this is just perfectly to answer objective question. So now this is not follow all the correct solution. Okay, for to find inverse. Okay, number 20. Given this function fx and gx with the graph, the info from the graph. Okay, so here, okay, f of g of negative 2 is equal to something. Find this one. Okay, to find this, so check. Okay, first thing is g of negative 2. G of negative 2. Check. Oh, this is function f. This is function g. This is line function g. Okay, and check. Okay, negative 2. So negative 1, negative 2. G of negative 2 here. Okay, so here touch this one at negative 3. So answer is negative 3. Next step, f of negative 3. When f of negative 3, this is f. Okay, this is quadratic for f. Okay, this is the quadratic. Then negative 3. So for quadratic, we touch here. Here consider negative 2. So negative 2. So we can say the answer is negative 2. The answer. Number 21. Given function, this function is piecewise function. Okay, then f is continuous. Okay, except this one to find, to check whether at this given here number here 1 and 2 is it f continuous or not. So from the piecewise function, change to number line. Okay, so consider at 1 and 2 only. Okay, so for this one, okay, all real numbers except 1 and 2. The function is, okay, this is the function. Okay, write the function here. Here, same function. Okay, and then when x is equal to 1, y is equal to negative 3. This is a point, just a one coordinate point. Okay, here is negative 3. When x is equal to 2, y is equal to 4. So this is also 1 point. Okay, 4. Okay, 4. And now we need to consider at this point, this point, as a 1 and 2. Okay, so let's discuss when x is equal to 1. Okay, to check whether continuous or not, need to satisfy the 3 conditions. First is f of 1. Given f of 1 is negative 3. Yes, negative 3. Second is limit. Limit x approaches 1. So for limit, okay, 1 from left, from right, here is equal function that is the function. So just find when x approaches 1 without finding negative and positive. Okay, so 3x, x minus 1 over x squared minus 3x plus 2. Substitute and substitute, get 0 over 0. This is indeterminate form. Okay, so for polynomial or polynomial, okay, we do factorize. Okay, factorize. Okay, limit x approaches 1, 3x x minus 1 over, confirm one of the linear factor is x minus 1. Okay, and x minus 2. Okay, this one can be cancelled. So the answer is limit 3x over x minus 2. Substitute 3 over 1 minus 2 is equal to negative 3. And check, oh, this one is, okay, this one is equal. Equal. Number 1, number 2 equal. Okay, so the third is number 1 is equal to number 2, or limit fx x approaches 1 is equal to f of 1. So conclusion, okay, therefore f is continuous at x is equal to 1. Okay, so check. Okay, f is continuous except, okay, so this is not the answer. Why? Because of f continuous, not continuous. F continuous at x is equal to 1. So this is cancel. So confirm this is not the answer. So this is not the answer. This is continuous at each real number. So actually real numbers, or from negative infinity to infinity. So the answer is here. This is one answer. Okay. So just to confirm, easy, this is the answer. Except x equal to 2. We're going to check one. Okay, again. Okay, do for this one, when x is equal to 2, check this one. Follow the 3 steps. First is f of 2 given f of 2 is equal to 4. Second, limit x approaches 2. Okay, and then using the same function. Okay, this function, or this function. Okay, like this one. 3x x minus 1 over x squared minus 3x plus 2. Substitute 6 1. This one is 4 minus 6 plus 2. So 6 over 0. 6 over 0 is undefined. Undefined. So this is confirmed not equal. And then conclusion, f is not continuous at x is equal to 2. So f is continuous at all real number except 2. So this is the answer. Okay, settle for number 21. Number 22, find limit. Okay, first thing substitute. 1 over negative 2 plus 1 over 2 is 0 over 0. This is considered indeterminate form. But actually, we try to equating the denominator. Okay, equating the denominator. Limit x tends to 0 to, okay, minus 2 plus x over 2 times negative 2 plus x over x. Next step, limit x approaches 0. Okay, this will cancel. So, and the answer is, okay, x over 2 negative 2 plus x. Here is times x. I'm going I use this concept. A over B over C is equal to A over B times 1 over C. Okay, and I can cancel this one. The answer is okay. Limit as approaches 0, 1 over 2 times negative 2 plus x. Then substitute 0, 2 negative 2 plus 0 is equal to negative 1 over 4. So the answer is here, negative 1 over 4. Number 23, find the vertical asymptote, if any, of the graph or the function given. Given is x minus 3 over x squared minus 9. First thing, find domain. Domain of this function. Let's say this is fx. Domain of fx. So for the ratio, everything below here not equal to 1. X squared minus 9 not equal to 0. Not equal to 0, okay? X minus 3, x plus 3 not equal to 0. Okay? And then so x not equal to 3 or x not equal to negative 3. And check before you say this is vertical asymptote. Okay, when x is equal to negative 3 and 3, you should check. Okay, let's say check when x is equal to 3. Okay, first case, find limit. So actually the domain is real numbers except 3 and negative 3. Okay, so take this one, take limit x approaches 3, okay, and x minus 3 over x squared minus 9, substitute, get 0 over 0. When 0 over 0, polynomial over polynomial, okay, factorize. X minus 3 over x minus 3, x plus, then cancel. Then the answer is limit x approaches 3, 1 over x plus 3, and substitute. Okay, get 1 over 6. Okay, so this is consider, okay, when x is equal to 3, y is equal to 1 over 6. And this is consider a point, just a point, not a vertical asymptote. Okay, and then check when x is equal to negative 3. Okay, substitute here. Find limit x approaches negative 3. Okay, let's say if you write like this, x minus 3 over x squared minus 9, substitute. Okay, substitute. This is negative 6 over 0. Negative 6 over 0 is equal to infinity. So now, here is negative, when x equals negative 3, infinity, y is equal to infinity. So, negative 3, infinity. One sign negative infinity, one sign value. So, this is considered x equals negative 3 is a vertical asymptote. So, vertical asymptote only one. That is this one, not this one. Okay?
Okay, question number 24. You were asked to find the dy dx when your y equals to u cubed over 3, and then when your u equals to x squared minus 2x plus 3. So dy du will be equals to 3u squared divided by 3, or this is equals to u squared. And as we know that u here equals to x squared minus 2x, so you just substitute. This is x squared minus 2x plus 3, and then you have a squared here. This is dy du. Whereas for du, you differentiate u with respect to x, you will have a 2x minus 2. Okay, or you can just factorize out the 2 here, you will have x minus 1. So using the chain rule, where we have a dy dx equals to dy du times, this is u, okay, times du dx. So we're going to write dy du x squared minus 2x plus 3, and then you have squared here, and your du dx equals to 2 times x minus 1. So this is actually equals to 2 times x minus 1 times x squared minus 2x plus 3 squared. So this is the answer here. Okay, using the chain rule. This is the chain rule. Okay, question number 25 here. You were asked to find the derivative of the f of x equals to e to the power of ln times ln x cubed. Okay, ln of ln x cubed here. Okay, before you answer this question here, you should know that if you have a e to the power of ln f of x, this is equals to f of x. Okay, so you should remember this one. Okay, e to the power of ln f of x equals to f of x. Okay, now let's continue with our question here. Okay, so we are going to start simplify this function here. So e to the power of ln x cubed will be equals to ln x cubed, or you may use the properties of log where this is equals to 3 ln x, and then when you start differentiate this, okay, this is a 3 constant remain here, so differentiate ln x, you get 1 over x here, so therefore the answer here will be 3 over x. So the second one here. Okay, question number 26 here. Okay, we're going to start with the y here equals to e to the power of negative x sine x. Okay, and then you were asked to show the following, where in the answer here we can see that there is second derivative and first derivative. Okay, but before that we're going to use the product rule here. So where your u equals to e to the power of negative x, and u prime here will be equals to negative e to the power of negative x, and whereas your v equals to sine x, and your v prime equals to cos x. Okay, so how to find the dy dx here? So since we're going to use the product rule, so your dy dx equals to u, v prime will be equals to cos x plus u v prime plus v u prime. U prime will be equals to negative e to the power of negative x. Okay, so since we can just factorize out the e to the power of negative x here, so we can write this as e to the power of negative x, so this is cos x minus sine x. Okay, so in the question here we can see that there is second derivative, so you need to proceed with the second derivative. So second derivative d2y dx squared, using the product rule, you take u, differentiate cos, you get negative sine x minus cos x. Okay, and then plus v u prime. U prime will be equals to negative e to the power of negative x here. Okay, so we are going to simplify this as factorize out the e to the power of negative x, and you will have negative sine x minus cos x. You have factorized out the e to the power of negative x, so you will have negative of cos x minus sine x here. Okay, so simplify everything in the bracket. So negative sine x plus sine x will be equals to 0. So negative cos x minus cos x will be equals to negative 2 cos x here. Okay, and then if you can see that there is no exponential function or cos in the answers, so we are going to substitute, or we are going to write this as a d2y dx squared. You bring to the left, so you will have a plus 2e to the power of negative x cos x equals to 0. Okay, so we are going to take e to the power of negative x cos x from the dy dx. Okay, so from here you have dy dx. Okay, so let's look at this one here. We have, so from here we want to find or substitute this function, okay, with, let's say, e to the power of negative x cos x will be equals to dy dx, and then plus e to the power of negative x sine x. Okay, so we're going to substitute this. This is e negative x cos x equals to dy dx plus e to the power of negative x sine x. Okay, we're going to substitute this one here. So you will have a d to y dx squared plus 2 times dy dx plus e to the power of negative x sine x, and then you will have this equals to 0, or you may write this as a d to y dx squared plus 2 dy dx, and then plus 2y. Okay, since this is you can see that e to the power of negative x sine x here equals to y. Yeah, so this is e negative x sine x, this is equals to y. So you will have y here equals to 0. So this is your last or final answer for this question. D to y dx squared plus 2 dy dx plus 2y. Okay, so which one? Okay, this is the answer here. Okay. Okay, question number 27 here, where you were asked to find the dy dx if x to the power of y equals to y to the power of x. X to the power of y equals to y to the power of x. So we're going to put ln to the both sides. So ln x to the power of y equals to ln y to the power of x. You can use the properties of log, where you can just bring down the y here to the front, y ln x equals to x ln y. And using the product rule, you can find the first derivative. You take y, differentiate ln x, you get 1 over x, plus you take ln x, differentiate y, you get dy dx. Okay, dy dx. And on your right hand side here, you're going to write this as x, differentiate ln y, you get 1 over y dy dx. Okay, and then plus ln y, differentiate x, you get 1. Okay, so we are going to rearrange all these terms and factorize out the dy dx. You're going to write this as ln x minus x over y, factorize out the dy dx. Okay, and on your right hand side you will have ln y minus with y over x. Okay, or this is equals to y ln x minus x over y times dy dx. You find the common denominator for both sides. This is x ln y minus y over x. Okay, so we want to find the dy dx in this case here. So this is on your right hand side, you will have x ln y minus y over x divide by y ln x. Divide by y ln x means that you multiply with y over y ln x minus x. Okay, so if I want to factorize out the negative, so I will have the y minus x ln y, and factorize out the negative for the denominator. So you will have x minus y ln x. Okay, and you simplify this dy dx. So you will have y times y minus x ln y over x times x minus y ln x here. Okay, so you check with the answers here. We have the second one here. Okay, so your final answer will be this one, dy dx equals to this one here.
Okay, number 28. If x is equal to a cos t, y is equal to a sin t, then find d to y dx squared. To find d to y dx squared at t is equal to pi of 4. First thing, you need to find dy dx. Okay, find dy dx, then find d to y dx. Okay, so to find dy dx, okay, we need to use chain rule. Differentiate x with respect to t. Okay, this one is a sin t. Okay, c. Differentiate c here. Remember, differentiate c in negative. Next step is differentiate y with respect to t. So a is equal to cos. Using the chain rule, dy dx is equal to dy du or dy dt, okay, times dt over d, or dy dt over dx over dt. Then substitute dy dt here over dx. Okay, a cos t over negative a sin t. Then simplify, cancel, get negative cos over sin is equal to cot. Settle for dy dx. Now we're going to find d to y dx. The formula is d dt dy dx over dx over dt. So, okay, first thing, you need to differentiate. Differentiate here, okay, dy dx. So this is dy dx, differentiate, and over dx dt. Dx dt just take this value, okay, for dx dt. Okay, here is negative cot tangent t. Okay, differentiate this one. Okay, negative cotangent is negative cosecant t squared. Okay, so negative is positive, right? Over negative a sin t. Okay. Simplify. Negative cosecant is 1 over sine. So 1 over sine, 1 over sine t squared. This is a, still got a. So the answer is here. Settle. Then when t is equal to pi of 4, just substitute d to y dx squared is equal to, okay, 1 over a. This is cube. Okay, cube. The sine pi over 4. Okay, sine pi over 4 is equal to, calculator, calculator give answer, set 2 over 2 or 1 over set. Okay, and simplify. Simplify, bring to here. Then d to y dx squared, and then negative 1 over a here is 2 sec2 over 8. Okay, here is sec2 cube is equal to sec2 times sec2 times sec2. Answer is 2 sec2. Okay, this one. Okay, and then simplify. This is 4, right? And then the answer is, bring 4 up here, 4 over a sec2. The next is a times sec2, then the final answer is, okay, this is 2, right? Cancel, get 2 sec2 over a. So check answer is then negative 2 sec2 over a here for the option. Okay, so here is no negative. Okay, here is no. Okay, so the answer is here negative 2 sec2 over a. Okay. The radius of the cylinder is increasing at the rate of 3 meter per second. Okay, radius of the cylinder increasing at rate of 3 meter per second. So here, radius R. Okay, increasing means that positive. Cylinder, this is pattern of the cylinder. Rate involve time or check the unit. The unit is m over s. So something over time. Okay, so it's equal to 3. Positive because increasing. So here mention radius. So the r dt is equal to 3 meter per second. Okay, the first sentence done. The second is its height is decreasing at the rate of 4 meter per second. So here h, this is h, decrease, so that's negative, and the rate is here. So dh, okay, rate is involved dt is equal to negative 4 meter per second. Okay, and the next step, okay, the rate of change of the volume when the radius is m is 4 meter and height is 6 meter is, so to find the rate of volume dv over dt when r is equal to 4 meter and h is equal to 6 meter. So now given this one, okay, so now first thing is using the dates. Okay, d e ds, dates, draw the equation, express to single variable. Okay, differentiate using the chain rule or implicit and solve. So now, okay, sketch, draw the diagram. Okay, D, draw the diagram. The diagram is cylinder. This is cylinder. Okay, this is cylinder. When the radius is increased, the height is decreased. So maybe the cylinder change in this form. Okay, and then this is R. R increase. Okay, R increase. H decrease. This is H. Okay, H decrease. So this is the pattern of the cylinder. Then EQ. EQ is equation. It mentioned the equation is volume. So find the volume for the cylinder. Volume is pi r squared h. Okay, the next step is find express in single variable. Now check, is there any info for to relate between r and h? Is something info or what is connection between r and h? So from the given question here, the relation between r and h is not given. So the given only dh dt and dr dt. In this case, to change variable to single variable is not happen. Okay, it's not possible because of no relation between h and r. Okay, so we need to differentiate V with respect to T. Okay, why? Because of we're going to find dV dt. Everything given in variable T. Okay, variable T. So here, differentiate is formula with respect to T. So this one, okay, skip. We differentiate. The next is differentiate. Okay, V pi r squared h. Okay. And then differentiate. Okay, V with respect to T. Differentiate on the right hand side with respect to T. So here is V pi r squared h. Differentiate dV with respect to T, get dV dt. Then for this part is using the product rule. So pi is constant. Okay. So next is just concentrate on this one. This one is actually U and V. U is equal to R square. V is equal to H. Now we're going to differentiate U with respect to T. Differentiate R with respect to T. Okay. And for V, differentiate V with respect to T. Differentiate H with respect to T. Everything is with respect to T. So U, R square, V, H. So now you get that one is du over dt. Here, differentiate this one using chain rule actually. We get 2r and add dr dt. Or show using the chain rule. Okay, for this one, this part, get dv dt. Then this one is dh dt. Now we're going to use product rule. Okay, du dt times v plus u times dv dt. Okay, product rule here. Y equals uv y prime, u prime v plus uv prime. Okay, so now u prime is 2r dr dt. Okay, and v is h plus u is r square and dvt is dh dt. Okay, and substitute the value given. The value is dr dt is equal to 3 meter per second. dh dt is equal to negative 4 second. R is equal to 4. H is equal to 6. Okay, and then to find dv dt. Okay, simplify 2 pi r. Okay, plus square this one. Okay, and substitute r. Okay, this one r. R. We should find r also. Okay, 2 pi r. Okay, and then r is equal to 4. dr dt 3. H 6. So r square is 4. dh dt negative 4. Okay, and I simplify. Okay, 2 times 4, 8 times 18 is equal to, okay, this one is equal to 1445 and minus 64. Okay, here also get pi. This one pi. Okay, pi. Okay. And then next is 144 pi minus 64 pi. Answer is 80 pi. Okay, 80 pi meter cube per second. So check the option. Okay, answer is 80 pi meter cube per second. So this is the answer. For number 29. For number 30, the height of the cylinder of maximum volume that can be inscribed in a sphere of radius E. So find H of the cylinder maximum volume. Maximum volume for the cylinder that can be inscribed in a sphere. Sphere, okay, radius A. So this is optimization maximum using the acronym D dot. Okay, the first D is draw. Second is EQ, equation, volume for the cylinder. EX, okay, write in one single variable. P1 is the first, okay, the first derivative to find the maximum or minimum, the extremum, right? And then D double prime is to test whether that one is confirmed maximum or minimum. Use D dot. Okay, so the first is D dot, cylinder inside the sphere. So this is sphere. Yeah, and the cylinder is cut here. Okay, so we're going to find the maximum volume for the cylinder. Okay, so now the sphere is radius A, or maybe like this. Okay, here. Okay, the cylinder. Okay, like this. Okay, going to find the maximum volume. But still the radius is equal to of the sphere is A. Okay, or maybe like this. Cylinder. Okay, and then the sphere. This is cylinder. Okay, okay. So the radius for the sphere still A. Okay, so now we're going to find this. The maximum volume for cylinder. So depends on the radius of the cylinder and H of the cylinder. Okay, so let's say we choose this one. Okay, draw. And the second is equation. Equation. So we're talking about the cylinder. Our concern is to find the maximum of the cylinder. So now the formula of the cylinder, volume for the cylinder is pi r squared h. Okay, so for the sphere is constant, radius A. The sphere is fixed, the volume is fixed. Okay, so the problem is only cylinder. So the variable is cylinder, r and h for cylinder, not for sphere. And then now the next step is to change this r, h to single variable. Okay, to find to express V in a single variable. So the problem now is we have variable R and H. Okay, this one. Okay, the cylinder. Let's say okay, cylinder here. Okay, this one. I write this here. Okay, sphere. And this one is cylinder. Okay, cross section. Okay, now radius. Okay, radius for sphere is A. Now here to here also A. Everywhere is A. Okay, A for sphere. For the cylinder, from here to here is radius. So here is H. So now formula is pi r squared H. Okay, this is the first section for the diagram. So find the connection between this one. So here that's something pi. The triangle here. Okay, triangle. This one also A. Okay. And here, this one. Okay. This is the radius for sphere A. R for cylinder. H over 2 for half of the cylinder. So we're going to use the Pythagoras theorem. A squared is equal to H over 2 squared plus r squared. Okay, we're going to find the height, h. So must get rid of r. The r as a subject. R squared is equal to a squared minus h squared over 4. Okay, just take this one. Okay, why? Because of we're going to get rid of r squared. Okay, take this one and substitute. Okay, so now is v is equal to pi a squared minus h squared over 4h. So this is in single variable h. The next step is differentiate. For the first derivative to find the maximum. Okay, the maximum volume for cylinder. Okay, before that expand. So a squared pi h minus pi h cube over 4. And dv differentiate with respect to h. A squared pi minus 3 pi h squared over 4. To find v maximum. Okay, and this one is equal to 0. Okay, why? Because of v maximum dv dh is equal to 0. Okay, it's 0. Okay. And then here is read one side. Okay, a squared pi cancel, h squared is equal to 4a squared over 3. Okay, h is equal to plus minus 2a over 3. And h always positive, therefore h is equal to 2a over 3. Okay, and check. Okay, 2a over 3. 2a over 3. This is that one. See, and then since this needed actually for objective, you get one answer only for h. Okay, you can skip to check to find the d double prime. Okay, but just want to show you this one. The next step is dv dx here. Okay, differentiate once again. Okay, right here dv dx dh. Okay, a squared pi minus 3 pi h squared over 4. And differentiate and find the second derivative. d2v dh squared. So this is constant 0. And then negative 3 pi h over 2. Confirm this is less than 0. Therefore, v maximum, okay, when h is equal to 2a over 3. Okay, so confirm the answer is this one. Okay, so all for pre PSPM extra KMPP. Good luck for your exam.